Hey everybody, so last chapter we were starting to talk about linear functions in terms of kind of the more basic linear functions with direct variation and slope-intercept form. And now we're going to move into some other types of linear functions and how to graph them, how to write the equations of them, and how to write different types of equations of linear functions. But before we get into that, I want to make sure that we list off all the things that we already know about linear functions. So take a second here, list off as many things that you know are true about linear functions. All right, on your list, you should have something like has a slope. And remember that slope is m equals y2 minus y1 over x2 minus x1. It's also the rise over the run. And when we looked at direct variation, we sometimes called it K, or the constant of proportionality, because we were able to create those proportions based on the information in a table or a set of points. So it has a slope, and that slope is constant throughout. It's a constant slope throughout that graph. And because it has that constant slope throughout the graph, it makes it linear. So the graph is a straight line. And when I say it's a straight line, I don't mean it's a vertical line. I don't mean it's a horizontal line necessarily. It could be, but that is just straight, and it goes on infinitely in both directions. So when I say straight line, all I mean is that it goes through points and it goes on infinitely in both directions with that constant slope. It doesn't ever go up or down. It just stays at that constant rate the entire time. So the graph is a straight line. Then we talked about a couple different types of linear functions. We talked about direct variation. And remember, direct variation looked like y equals kx. And with direct variation, we knew that it went through the origin. It goes through the point 0, 0. So those are super easy to graph, because if you know the slope, you know the whole graph, because all you have to do is plot the origin, use that constant of proportionality to find that next point. And then we briefly started talking about our first type of kind of major linear function. This one was kind of just a basic introduction, but then our major first type was slope-intercept form. And we'll get into more of the details on what slope-intercept form looks like as we go along in this video. But these are kind of the basics of linear function here. It has a slope, it has a constant slope. That doesn't mean that it's constant, meaning it's horizontal or vertical at the same time. That just means that it changes by the same amount each and every time. So if we looked at a table, we would be able to find that proportionality. We'd be able to find that change in y over the change in x to be the same every single time. All right, so that first type of major linear function that we've talked about so far has been slope-intercept form. And I want to make sure that we cover it again, because it looked like a few people had trouble with it on the test in terms of how to graph in slope-intercept. But if we remember, slope-intercept form looks like y equals mx plus b. And I know I've done this a million times with you guys, but there's a reason why I do this. I want to make sure that we know what each variable stands for, so that way if you're not sure on how to do something, go back to what each variable stands for and use that knowledge to do something else. So we know that y stands for our output, or in this case, our outputs, because we can have multiple outputs in this function. Remember, m stands for our slope, x stands for our inputs, and b stands for the y-intercept. So if they give you an equation in slope-intercept form, it tells you two major things. The first major thing that it tells you is the slope. Second thing is it tells you the y-intercept. And we know that from the title of this type of equation. So the two major things that it tells you is the slope and the y-intercept. So if I go to graph this, if I want to graph the function y equals negative 2x plus 1, then on my graph, it's going to tell me two major things. It's going to tell me my slope, and in this case, my slope is this negative 2. So m equals negative 2 over 1, because remember, if it's a whole number, it's always over 1. And it tells us that my b is this plus 1. And remember, when we're writing the y-intercept, typically we want to write it as an ordered pair. And whenever you write an ordered pair, you need those parentheses. So this tells us all we need to know about the graph, because it tells us that our beginning amount, or our beginning number, is at 0, 1. So I'm just going to plot the point 0, 1, and that's my b value. And then I'm just going to use my slope to find other points. I know that negative 2 is my rise, and 1 is my run. So from here, I'm going to rise negative 2, meaning I have to go down 2. 1, 2 brings me down to negative 1, and then I have to run 1. I'm going to go over 1. 2 points is all you need to draw the line, because then from there, all we have to do is draw our line through those points and try to draw it as straight as possible. So my line is going to go through 1 on the y-axis, and then it's going to have a negative slope. Anytime that you're given an equation or what the slope is, first thing that you should notice is whether the slope is positive or negative. If the slope is positive, it's going to be going up like this. If the slope is negative, it's going to be going down. So that's the information that that equation gives us. Our next type of linear function that we're going to look at is called point-slope form. And just like slope-intercept gave us two things, the slope and the y-intercept, point-slope form is going to give us two things. Can you guess what those two things are? Good. Point-slope gives us a point and a slope. Now, this one looks super confusing, but it's really not that bad, so bear with me here. So point-slope form looks like y minus y1 is equal to m times the quantity x minus x1. So looks super confusing. It's got multiple x's, multiple y's in there, but let's break it down just like we have been. Y stands for our outputs. And just like in slope-intercept form, y is going to stay y. We're not going to plug anything in for that to write the equation. y1 and x1 I'll get back to because we haven't talked about that yet. Let's go to what we know. We know that m is the slope. We also know that x is our set of inputs. Now the confusing part is this x1, y1. So we know that this equation is going to give us point slope. Well, we already know that m is the slope, so with this x1, y1 has to give us a point. So the x1, y1 is just a point that is on the line. So x1, y1 is a point on the line. And that'll make more sense once we look at a couple examples, but remember that that's what this equation is going to give us. Sometimes it'll give us the y-intercept, and that's great, but sometimes it'll just give us some random point that's on the line that we can use to help us graph it, just like we did in slope-intercept. Plot the point, use the slope to find other points. So let's look at an example of this type of equation. If I have the equation y minus 4 is equal to 1/2 times x minus 3. Well, what information does this tell us? It gives us a point and it gives us the slope. So let's look at what our point is. So we know that the point is in the form of x1, y1. So here, the original equation has a minus x1. So when we see minus 3, well, 3 is actually then a positive number because it's the same sign as up here. So if it's a minus sign, it's kind of opposite. So the x1 is actually a positive 3. And our y1, same thing, because it's y minus y1. So instead of y minus y1, we replaced y1 with 4. So we have the point 3, 4. So it gives us a point, and then it also gives us the slope. What would the slope be in this equation, do you think? Good, the slope should be m equals 1/2. So then if we looked at that on a graph, if I draw a quick sketch of the graph over here, I know that it's got the point 3, 4. So I'm going to go over 1, 2, 3 in the x direction, 1, 2, 3, 4 in the y direction, and I know that I have a point right there. That's the point that they give us is on the line. Then I can use my slope to find other points. My rise is 1. My run is 2. So I'm going to go up 1, so up 1, and then over 2. Up 1, over 2. Now you can see I'm kind of getting to the right edge of my graph here. So what I can do is I can go opposite this. I can rise -1 and run -2. So I can rise -1 and run -2. So I can go down 1 and left 2. So I end up right here. But again, all we need is 2 points to draw that line. So I'm just going to make my line through there and put arrows on both ends. So just like slope-intercept form, point slope is going to give us some different information. It's going to give us a point and a slope. All right, so this problem here says to write the equation of the line going through the points 3, 1 and 6, 3. So first, if we look at this, is trying to write it in slope-intercept. Let's do slope-intercept first, and you'll see why we might want to use point slope instead. So if I do slope-intercept first, in here in red, we need to find 2 things. What 2 things do we need to find to write it in slope-intercept form? Well, we need to find the slope, and we need to find the y-intercept. So let's find our slope first. To find the slope, remember we have to do y2 minus y1 over x2 minus x1. So if I plug in my points, I get 3 minus 1 over 6 minus 3 is going to give me 2/3. So my slope here is 2/3. Now I need to find my y-intercept. Always check in the points. Do they give us a y-intercept? Well, no, because we're looking for a point 0, b, and neither one of those points gives us 0 in that x-coordinate. So far I know that I need y equals 2/3 x plus b, but I don't know what that b is yet. So what I'm going to do is I'm going to plug in one of my points. I'll plug in my first point here. 1 equals 2/3 times 3 plus b. Now all I need to do is t-chart and solve for b. 2/3 times 3 is going to give me 2. Subtract 2 from both sides, and b is equal to -1. So then I know my point is 0, -1. Now all I have to do is put it all together, write my equation. So step number 3 here, my equation then would be y equals 2 over 3x minus 1. So my slope is 2/3, my y-intercept is -1. Now this one wasn't too bad because solving for b wasn't too bad because the fractions kind of canceled each other out. Kind of 2/3 times 3 gave us a whole number instead of another fraction. But if you could see, if we had a bunch of different fractions in here, this would be a little bit more difficult to solve. And I'll show you that doing it in point slope might be a little bit easier. So over here, I'm going to do it in blue in point slope. So same thing, I need two things. I need a single point and I need the slope. So the first thing is I'm going to write down one of my points. I can choose either one. Either one is going to give me a valid equation. If you choose this one, great, you'll get one type of equation. If you choose this one, great, you'll get an equation that looks different, but is actually talking about the same function. So let's choose 3, 1, because I used it over here as well. So let's use the point 3, 1 as my x1 and my y1. Second thing I need to do is I need to find my slope. Well, we already did that over here, but I'll rewrite it just so that we have it. So my slope is going to be y2 minus y1 over x2 minus x1. So we had 3 minus 1 over 6 minus 3 to get 2/3. So I know my slope is 2/3. I know my point is x1, y1, 3, 1. Now all I need to do is write my equation. So I know it's going to be in the form of y minus y1 equals m times x minus x1. All I have to do is plug in my information. Y minus, well, I chose my y1 as 1, is equal to, my slope is 2/3 times x minus my x1 is 3. And that's all I need to do, because this equation tells me some valuable information. This equation tells me valuable information, but so does this one. They tell me different types of information, but they tell me about the same function. So next time it asks you to write an equation, make sure you think about which type of equation is going to be easier. Because if they give you 2 points, all you have to do is plug it in. You need to find the slope and then plug it in. Whereas if you're writing it in slope-intercept form, you have to do a little bit of solving to get it to get that y-intercept. So that's the basics of point-slope form. So we've got slope-intercept, point-slope form, and then our last type will be standard form, and we'll look at that a little bit more in the next few days.